Thanks. Yeah, so before I start, can I have a show of hands? How many of you have raced in the virtual league? Right, 2. And how many of you have raced in the physical league? Physical league, virtual league? Oh, both, right. Okay, good. So before I go into the actual content, I'll just introduce myself. So I'll introduce myself by talking about my B-hack, right? This big, hairy, audacious goal. I started my journey with AWS, well, at least in terms of certification, back in 2017, and I've got 8 certifications so far, and my next certification was supposed to be the machine learning certification, and I wanted to do the certification with the right background, right? But I didn't have the right background. I have no PhD, I'm not a math major, and I have no experience in ML. So I was looking for a way to get started, right? And I came across this thing called AWS DeepRacer, right? So it was the perfect way for me to get a nice, easy introduction into machine learning and reinforcement learning. And as part of that journey, I set myself a goal, which was to use DeepRacer to learn about reinforcement learning, and at the same time aim to be top 3 in the world, right? So that's my B-hack. And my journey started at the Singapore Summit in April, all right, the AWS Summit in Singapore. I actually placed 7. Not too shabby, but not too good, right? So I not pleased with that. I went on to another race at ReMars here in Las Vegas. At ReMars, I was 4th, sadly. So I changed my goal to just having a top 3 podium place in any summit, right? So I went on to the next summit in Hong Kong, and again I was placed 4th. So close to a podium finish. So after that, I ran out of money, so I didn't have a chance to travel, and I saved up enough to have one final trip to Toronto, and that's the last race of the season, of the summit season. So I went to Toronto with the sole aim of being on the podium, and thankfully I got number 3. So I got my podium place, right? So the nice side effect of doing that was that I was actually placed number 1 on the as a top points getter, right? So as the top points getter, I actually had the privilege of coming back as a championship cup finalist, right? So that's me, and that's my journey with AWS DeepRacer, and this was my good lap in Toronto. So this was around a 9-second lap, and then the next lap was about 8.352, and this last lap here actually got a lap time of 8.152, right? So this 8.152 got me enough to get a podium place. So I'm here to talk about simulation to reality, right? And through all these experiences racing at the summit, I came to this conclusion: any model that I had that was faster than 14 seconds in simulation did not work well at the summit tracks, right? So in the physical track. Not sure what's the science behind it, but that was, but that was what I experienced. And in fact, the model that did well in Summit actually did about 20 seconds in simulation. And I just tried that same model here, and it's doing about 8.9 seconds at the track here. So it's stable. So it was trained for stability over speed, and it seemed to work well on the physical track. right? So the other thing I realized was, so as I played around with the action spaces, in the virtual league or in simulation, you can go with very small action spaces, right? Single speed, small number of steering angles. So that works well in virtual, but when I try it on track, it's very hard to get a good lap when you have a very small action space. So that's the other thing I learned. And as I went through this process of racing at the league, the Summit League, I realized I needed a way to have a more data-driven way of analyzing my models. So I'm going to show you some of the data-driven analysis that I've done. And yeah, so it's super important. So the first thing I looked at is obviously would be the console graph. So the graph here is what we typically see in the console, and we'll be looking out for laps that are at 100% progress mark, right? So if you see the purple dots at the top, you know your model is doing well, and you're looking for upward trend, of course. And then as it trails off, you know that your model is converging, and try not to overfit by overtraining beyond this, right? So that was the initial learnings from the console graph. And then I got involved with the deep racing community, right? So people like Lyndon and Thomas, especially Thomas, who's expert in the log analysis. So he has a talk. He had a talk yesterday on log analysis, so I won't go through that. But basically, it's a notebook that gives you great analysis on your models and your training from the logs of your DeepRacer logs, the SageMaker logs. So I won't touch much on this since it's been covered in the other talk and it was recorded. For myself, I have a Unix background, so I come from a Unix background, not a data science or Python background. So I have very little knowledge about notebooks, but I'm a great Unix scripter, right? So to any Unix guy, everything looks like every problem can be solved with Unix scripts, right? So that's what I did. I did all my log analysis using shell scripts. So the first thing I did was to plot the rewards, average rewards over time, which was quite similar to what you see in the DeepRacer logs. And I went on to look at entropy, how entropy correlates with rewards over time, right? So obviously entropy starts high and then goes down as you train, and rewards go up, so they are inversely correlated, right? And I learned this from Sahika, who I met in REMAS, at REMAS. So she told me this concept about entropy going down and rewards going up. So I wanted to check that my models are training well according to that theory, right, or to that expectation. So that's what I initially plotted. So every model that I trained, I plotted it in real time to make sure it's trending this way. And about entropy, so there are two concepts around entropy. So there's the entropy which you specify as part of the hyperparameters when you trigger off your training, and actually that's what's known as beta entropy, right? But the entropy that I'm talking about here when I plot my graph is actually the current entropy of the policy of your model, right? So as you train, the amount of randomness in your model, that's the current policy entropy, right? It's different from the entropy, the beta entropy that's specified at the start of your training as part of the hyperparameters. I then began to overlay the progress made by my model, as in terms of lab progress, over time, right, on top of entropy and rewards. And here you see that a plot of max progress plotted, which is the green graph, plotted on top of entropy. And you'll find that even though entropy continues to go down and rewards continue to go up, the max progress has stagnated, right? So max progress stagnated no further than 40%. So here, this is a graph of a bad lab, or rather a bad model, right? So having rewards and entropy alone, you can't confirm that your model is good. So in this case, by adding on graph of max progress, you can see that I identified a bad model, right? So that's another thing I looked for. So over time, I added on another graph, which is that of the percentage of completed labs. So what you see here in green is the max progress in any iteration, right? So over an iteration of 40 labs, say the max progress among the 40 episodes, you have completed labs, then it will appear as 100%, right? But that alone doesn't tell you how many labs are completing the 100% of the lab. So that will be this pink line, which shows once you started getting 100% labs, you get more and more labs hitting 100%. So this part of the graph goes up, right? So I'm also tracking the worst cases among all episodes, which is the mean progress, minimum progress, and that's this brown line here. So this would be a typical graph of what I would deem a good model. So this is a plot of the model that I was just running over there, which did an 8.9 second lap. So this is, I would typically look for a graph that looks like that when I do my training. And if we look at it over time as a time lapse, this is roughly how it looks like. So as entropy goes down, rewards go up, and we start to see labs completing. And soon you'll find that you'll have regular lab completion, so regular 100% labs happening. And you will see the pink line starting to go up because we are getting more and more labs doing 100%. And then you see the entropy hitting a minimum and rewards hitting a maximum, and then they start trailing off, right, or start plateauing. So now we know the model has more or less converged, and if we train further, it will be overfit, or it may start to do worse. So I would typically end my training just before it goes back down, or just before it trails off. Right, so this is already slightly over-converged. I would end my training around here, or go back to a checkpoint just before the maximum rewards. Questions? Any questions? No? Yeah.
What plotting program?
What plotting?
Plotting program.
Oh, what plotting program? Yeah. So the question was, what did I use to plot this? Right. So I'm using GNU plot. As I mentioned earlier, I'm a Unix guy, so every problem I solve using shell scripts. So this is a GNU plot using shell scripts. So I'm looking for someone who can partner me in converting this to a notebook, so that we can make it open source and add to the log analysis notebook as well. So I started to move on to look at how we can optimize steering angles as well. So I think some of you, or most of you, are also doing local training, right? How many of you doing local training? Okay, quite a few. So I started looking at how to optimize the angles, the steering angles, and I did that by plotting the average angle at every single waypoint, right? So at every single waypoint with the logs from the sim trace logs, I took the average of the angles taken at every waypoint, and I start to see a trend in terms of how the car is steering at different parts of the track. And after doing that, I basically tried to do a model trying to optimize or exploit that knowledge. So in this case, the max angle for left turn was about 20 degrees and right turn was about 10 degrees. So I added a buffer of 5 degrees each way, and then I trained it and I ran a lap, and it was doing pretty well. So this is in simulation. It did about 9-second lap, right? So by exploiting that knowledge about steering angles, yeah. So that's another way we could optimize. So if I take everything together, then this will be my training dashboard, right? So as I train every model, I get a view on steering angles, about entropy versus rewards, number of laps completed, and also the gazebo graph, gazebo image as well. So this is possible with local training. With training on console, I guess it's also possible to map all this out, but you would need to have a way to do a real-time download of the S3 logs. Right. Okay. So after that, because I'm one of the finalists in the championship cup, I started to analyze the championship track as well once it was released, and I was looking for another way of analyzing, and I further enhanced the steering analysis with the analysis of the average distance from center. So the green plot here overlaid over the blue plot. The blue plot will be the average steering angle taken at every waypoint, and the green shows the average distance from center, whether left or right, at every waypoint. So that gave me insights into am I steering or turning into the optimal racing line at every bend, right? And it helped me to analyze at which point am I steering left and keeping right, or steering left and keeping left, right? So in this case, it's steering left while keeping right, and at this turn, it's steering left while keeping left, right? So having some additional data to look at and to design your reward functions. Okay, so finally, I would like to also show you a way you can test your models, right? So many of us have cars or have access to a DeepRacer car, but may not have access to a track, right? So having a car without a track is not a good way to test your models. So I found a simple way to do, a quick and dirty way to test your models, just by doing something simple. So at the top here, you will see a model that's not doing well on the physical track, and at the bottom you will see a model that's doing well in the physical track. And I'll play the video and you can observe what the difference is. So at the top, when I do this, you will see that the wheels seldom turn, right? It tends to go straight all the time, or most of the time, and it doesn't turn very often. Whereas in a model that I know is doing well on the physical track, you can see that the wheels are twitching and turning much more often. So this is a quick and dirty way I use to test my models whenever I don't have access to a track, even though I have access to a car. All right, so that's it from what I have to share, and whatever I've learned is all because I got involved in this wonderful community, the DeepRacer community founded by Lyndon. This is how you can get involved if you haven't already. Just scan the QR code and get involved. And And this would be my LinkedIn profile. If you would like to connect, just again scan the QR code. Right. Any questions?
Thank you. Is there any way that we could also use the code that you have used?
Yeah.
Do you have your own?
Yes. So I'm definitely going to open source it, right? But I'm currently not sharing it yet because I'm just wary that if I'm sharing shell scripts, it will just confuse everyone. So I'm trying to look for someone to partner to sort of port it over to a notebook so that it's more consistent with the log analysis notebook, right? So that we can extend the log analysis notebook to make it consistent for the community. Because while some people are able to read and understand the shell scripts, I think it's sort of diverting from the notebook way of doing log analysis. So I'm just looking to partner, maybe Thomas. Just reach out to me on LinkedIn. I will share with you individually as well. Yeah. Questions? Yeah.
I'm actually completely new to this DeepRacer. I just had a session this morning. So I'm maybe asking a vague question here. So the race is to cut down the time, like how much time it's taking to take the whole track. Yeah. So have you thought of like trying to drive within the inner edge of the circle?
Right. So the question is about optimizing your reward function to exploit racing lines, right? So to have
on the inner side,
to take the inner track, minimize the distance traveled by the car at every step of the way. Yes, I've tried that. I've tried code that exceeds 10,000 lines of code. So I have a reward function that's more than 10,000 lines. So my conclusion from all the testing is keep it simple. Don't try to tell the car what to do. Trust that reinforcement learning will do its job. So just reward the car when it does something well, rather than tell the car what to do. So yes, you can reward for optimal racing line, but just be careful about whether you're crossing the line of telling the car how or what to do, right? So focus on rewarding, don't focus on telling it what to do. So that's a fine line there.
Yeah, so I'm actually wondering, I really love your dashboards. I've always loved watching your videos with dashboard, but I'm wondering how much of it is what you've already known and how much of your dashboards and configuration is something that you actually learned with DeepRacer?
How much of it is what I already known? Sorry, just need to clarify the question.
Yeah, just when you set up the dashboard, you do all those scripts that like run all those live graphs. How much of it you've used before? How much of this you had to actually learn because you just wanted to have those things?
Yeah, I learned everything from scratch, right? So while I'm good at scripting, I've never plotted anything on GNU plot. I've never created such graphs before. So everything was done out of necessity because I wanted to have better models or a better way to analyze my training data, right? So it's all about being data driven and not just staring at the gazebo thing, not staring at the car going around the track and making decisions without data, without justification. So I was looking for data to drive design decisions, whether it's reward function design or hyperparameters or the action space. Yeah. So action space would be when I was looking at steering angles and stuff. Yeah. So most of it are from scratch after getting into DeepRacer, not before that. Okay. Yeah. No questions. I'm done.
Thank you, Ray. Let's give it for Ray Goh. Thank you.